Welcome to My Secret Math Tutor. In this video, we're going to work with problems that involve motion, specifically position, velocity, and acceleration. So remember that we could be looking at a function that, say, gives us the position of an object, like its height over time, and its derivative gives us its velocity. But there's a lot of other terms that you want to know as well when working with these problems. So example, if your original function is the position, the first derivative is your velocity. And the second derivative is your acceleration, and the third derivative is the jerk. So look for these key terms in these problems so you know which derivative you need to take. All right, let's go ahead and move on to the example. For this example, I have a position function, t cubed minus 12t squared minus 45t, and it represents the position of a particle in meters after t seconds. So we just want to answer just a few questions about it. First of all, what is the velocity of this particle after t equals 0? So notice how we're getting that key term in here, velocity, and we want to know what is the first derivative of this position function. So let's go ahead and find one derivative of this thing and mark it as our velocity. So it looks like we can use the power rule on it. We'd simply take the powers, drop them down in front, and reduce the power by 1. All right, so this represents my velocity. Now we can figure out what the velocity is after 0 seconds by plugging in a 0. All right, that looks pretty good. So I have 0 for this entire term minus 0 for this entire term, and the only thing that is left is 45. And since the position is in meters, with respect to, say, seconds, this would be in my meters per second. All right. Now, the second one, we want to know what is its acceleration. So that's two derivatives of the position or one derivative of our velocity. So let's see, velocity's derivative. We'll mark this as acceleration. And I'm looking at this function right here to take its derivative. So let's bring down that power. Minus 24. Derivative of a constant would be 0. So now I have my acceleration. We can figure it out after 1 second by plugging in a 1. 6 times 1 minus 24. 6 minus 24. Let's go ahead and write this up here. Negative 18. All right. And I'll label this in meters per second squared. So this is our acceleration. Let's see if we can answer just a few more questions about this particle. So this is my same position function, and now I want to know what is the velocity when the acceleration is equal to 0. So I'm seeing these two key terms in here. I have a first derivative and the second derivative of position. We can borrow both of those. But I just really want to focus on the second derivative. When is the acceleration equal to 0? So our acceleration was 6t minus 24, and we want to know where is this thing equal to 0. Okay, so solving this, I can move the 24 to the other side, and then divide both sides by 6, giving me a 4. Now, careful on what this actually means here. This says after 4 seconds, I know that my acceleration is 0. But if I really want to know the velocity, now I have to substitute this into our velocity function. So let's give that a try. So our velocity was the 3t squared minus 24t plus 45. Now let's go ahead and put a 4 in there. So 3 times 4 squared minus 24 times 4 plus 45. All right, so a little bit of simplifying to do with this one, not too bad. I have 3 times 16 right here. That's a 48. Minus 24 times 4 is 96. And plus 45. So combining all of these numbers together, I get a negative 3. And this number here is our velocity. Let's go ahead and label it in meters per second. So what is the velocity when acceleration equals 0? -3 meters per second. All right. Kind of tricky, had to pick that one apart. Let's do one last one. What is the total distance traveled from t equals 0 to 4? Now, at first glance, it looks like this one is simply talking about the position of the particle. You know, where is its position after 0 seconds, and where is its position after 4 seconds. But actually, there's a little bit more going on with this when you're talking about the total distance traveled. To think about what might be working here, think of what happens when, say, our particle starts at a spot, goes in a certain direction, and then maybe it actually turns around. So I would want the total distance, or like this distance plus this distance, and my position function won't necessarily give me that directly, because, you know, if I just took times 0 and times 4, it might not be enough. It might not actually count there and back again for my distance. So the first thing I need to check is, you know what, is there any time along the way does my particle change direction? Because if it does change directions, then I want to check the distance from that point to where it changes direction, and from where it changes direction to the end. And one way we can see where it changes direction is by looking at its velocity and where it is equal to 0. So let's go ahead and borrow our velocity and set it equal to 0. So 0 equals 3t squared minus 24t plus 45. All right, so let's see. Everything in here is divisible by 3, so I can make the numbers just a little bit smaller. T squared minus 8t plus 15. And it looks like this definitely factors into a t minus 3 and a t minus 5. So I know that my velocity will equal 0 at two spots, when t equals 3 and when t is equal to 5. Now, just that information right there is not enough to see whether it actually changes direction. After all, maybe it just stops at 3 and then continues on after 3. To figure out what is really happening at both of these points, I'm going to check the sign of the velocity, whether it's positive or negative, around these key values. So here's 3, and here's 5, and we'll be testing these into the velocity function, okay? So think of a number, say, less than 3, maybe 0, and plug it into the pieces for our velocity. I'll be putting it into the t minus 3 and the t minus 5. So if I was to put 0 into here, I would see that this little portion would be negative. If I put 0 into here, that portion would also be negative. All right, now testing something between 3 and 5, maybe like the number 4. If I plugged it into here, 4 minus 3 would give me a positive value, but 4 minus 5 would give me a negative value. All right, and lastly, something greater than 5, maybe something like 6, into each of these portions of my velocity. It looks like both of them would be positive. So by looking at the signs of the individual pieces of the velocity, now I can put those together and see what my total velocity is doing. So from time 0 to time 3, it looks like my velocity is positive. From, say, 3 to 5, I would have a positive times a negative, so my velocity is negative. And right there, I know that it just changed directions, because my velocity was positive, then it switched to negative, so it must have turned around right there. Okay, on the very end, positive times a positive is another positive, so 5 is another spot where it has changed directions. So here's the really important thing that I'm picking out of here. My particle changed direction at 3 and 5, and if I'm really interested at the total distance traveled from 0 to 4, it means I need to break this down into two pieces. First, we'll figure out how far did it travel from 0 to 3, grab some sort of distance from there, and then we'll take a look at how far it traveled from 3 to 4. We'll look at both of those, okay? All right, so let's start off with the distance. Say from 0 to 3. To figure out that distance, we can just simply use our position function at time 0 and time 3. So imagine plugging 0 into your position function. I guess we better write it down if we're going to use it. So that's t cubed minus 12t squared plus 45t. Okay, so what happens when you plug a 0 into your position? Well, everything has a t in it, So everything would just go to 0. All right, so where's the position after 3 seconds? Well, this one does require a little bit more work, but I think we can do it. So I'd have 3 cubed minus 12, 3 squared, plus 45 times 3. All right, let's see. Some of these simplify. So 3 cubed, 27, minus 3 times a 3 squared, so that'd be 12 times 9, 108. And 45 times 3 would be plus 135. So its position, now it's at 54 meters. So in terms of how far did it go from, say, 0 to 3, I can look at the difference of these two things. And that tells me that it traveled 54 meters. All right, now let's go ahead and do the distance from 3 to 4. So we would want to look at what is the distance at 3. And fortunately, we've already done that up here, so that was 54. And we'll also look at the position at 4. So this one does require a little bit of work. Let's go ahead and plug in that 4 and see what we get. So 4 cubed minus 12 times 4 squared plus 45 times 4. All right, simplifying this guy down, I would get a 64 minus, 12 times 16, so 192, plus 45 times 4, 180. All right, 64 minus 192 plus 180, that is 52. So to get my distance, I want to see how much it has traveled from 54 to 52. So we'll subtract those guys. And I can see that it has traveled 2 meters during that distance. All right, so in the big picture, here's what we're really getting. So I had my particle start at, say, 0. And then after 3 seconds, looks like it traveled a total of 54 meters. Then from 3 seconds to 4 seconds, I know it turned around. It went the other direction, but it didn't go very far. It only went 2 meters the other direction. So I know that it went a total of 54 plus 2, or 56 meters. All right. So be very careful when working through problems like this, so you know whether you're looking at the first derivative or second derivative, or even possibly even the third derivative. Also, be very careful on when you're solving many of these different equations to see if you're really getting something like a velocity, or you've simply solved it for a time. That can make a big difference in what you need to do with that information. All right? If you'd like to see some more videos, please visit mysecretmathtutor.com.